Okay, pause and copy very roughly. I'd like to talk about why FTC2 is true. So, we've got a function. We're going to look at the area under this function from A to X. Not B here, because we actually want to make a function out of this area. So we're going to call the area here. We're going to call that g of x, the area. So in an equation, we have g of x is the definite integral from a to x of the function f. Now, careful. We've already used the letter x here, so we can't use it again. We have to choose a different letter, and the usual thing is to go with a t. Okay, function f and g represents the area under f from a to x. Okay, now, for reasons that will become apparent later, I'm going to find g prime of x. Okay, what's g prime of x? Well, it's going to involve this familiar difference quotient. You remember from earlier in the course. We take this guy, we divide by h, and then we do a limit. Okay, so I'm going to leave the limit out for now, but I want to focus on this numerator here and interpret that on my graph. So g of x, that's this area that I've done over here, from a to x, and g of x plus h is a bit more area, right? So if I put a x plus h here and do my dotted line up, then g of x plus h is the area, which I'll do in red here. It's a little bit more area here. Now, what's the difference? What is the difference between the smaller area, g of x, and the bigger area, g of x plus h? Well, it's this bit right here. So let's note that. This area is, not g of x plus h, it's g of x plus h minus g of x, rather. This area right here. Because remember, the bigger area, this is g of x plus h, and then when I subtract this smaller area here, what's left is this almost rectangular thingy there. Okay. Now let's look at this area. Let's grab this point here, grab this point up here, this guy. That guy right there, let's label it. Well, the x value is just x, and the y value is f of x. Now I want you to imagine this rectangle here. This rectangle, I'll use a different color. Let's go purple here. Purple. Why not orange? I'll make a nice clash of colors here. The area of this rectangle is base times height. The base is h. It's the difference of these two things down here. And the height is this y value here. So h times f of x is the area of my orange rectangle. And what do we notice? We notice that if I use red here, red is a little bit bigger, right? This area here is a little bit bigger. It goes up to the function there. That. And it comes down. Anyway, so red and orange are approximately equal. That's the point I'm trying to make here. So the point I'm trying to make here is that this difference is approximately equal to h times f of x. So I'll write that here. Approximately equal to h times f of x. I'll divide by h. And this is equal to, well, just f of x. Okay. What does that tell us? Well, it's all very rough, but hopefully you're convinced, at least partially, that when I do a limit here, I can maybe do a limit here, and this doesn't depend on h, this doesn't depend on h here, so I get just f of x here. And I end up with g prime of x is just f of x. Now this is what we call FTC1. More specifically, in this course at least, we assume that f is continuous. So this is FTC1.